Hello students, today I shall discuss 2 or 3 problems. I selected it, and to my assessment that problems will be very conceptual and it will boost your confidence and concept both. Let us go to the problem. Right away. My topic is distribution of charges on parallel conducting plates. If any, there are some parallel, maybe 1, 2 or 3 parallel plate conductors. If one is charged, how the charges by induction, how the charges will be distributed in different plates, that is the problem. I shall solve the problem from the very basic concept, and then I shall give you a trick how to solve the problem very quickly in exam hall. Okay, these are 2 metal plates, conducting plates. These are plates A and B. A and B, 2 conducting plates. These are all conducting plate, metal plates. This is metal plates, and this is also metal plates. Okay, metal plates. Okay, A and B have charges Q1 and Q2. Now, find distribution of charges on different things. Find distribution of charges. Distribution of charges. That is the question. Okay. How many surfaces are there? These are 2 surfaces upper lower, these are 2 surfaces upper lower. In every surface there will be charge, and you have to find out what will be the main principle behind this problem. Main principle is that within the metal electric field is 0. On this principle you have to solve the problem within the metal, within conductor, E equal to 0. Okay, and another idea we have gained during theoretical discussion, if it is a charged sheet, and it has surface density of charge sigma, then charge sheet, it will have electric field intensity sigma by 2 epsilon 0 in this side, and also sigma by 2 epsilon 0 on this side. This will be, field will be normal to the plates, and you see that this electric field does not depend upon the distance from the charge plate. Okay, these 2 ideas. Within the conductor E equal to 0, and charge sheet has electric field intensity sigma pi. Charge sheet has electric field intensity sigma by 2 epsilon 0. These 2 ideas will be applied in this problem to solve it. Okay. You take any of the 2 plates, suppose these plates is taken. Point P. At point P, EP equal to 0. At point P, EP equal to 0. Suppose this has another concept. Isolated system has charge conjugate. Isolated system has charge conjugate. These 2 plates, if I take these 2 plates are as a system, then Q1 plus Q2 will be constant. If I take these plate as a system, then Q1 will be constant. Okay? Let us consider lower plate charge is Q. Then in upper plate, what will be the charge? From conservation of energy, Q1 minus Q. Another idea you have to take the faces surfaces facing each other, these two surfaces, upper of this lower plate and lower of the upper plate are facing each other, surfaces facing each other will have equal and opposite charge, These concepts you have to bear in mind. Isolated system has charge conserved. Okay. Yeah. Within the conductor E equal to 0, surfaces facing opposite to each other, surfaces facing each other will have equal and opposite charges. Then what will be the charges here? Minus Q. Okay. But this charge is also conserved. Total charge of these plates must be conserved, that is always will remain Q2. Then what will be the charge of the outside? Q2 plus Q. These two added will give you Q2. Okay, the distribution of charge I have given you. Now you have to find Q. If you find Q, then all surfaces, charge on all surfaces will be found out. Okay, let us go. I am wiping it out. So let us take the problem. EP, electric field at the point P, EP equal to 0. Yeah. How many electric fields EP is? How many electric fields give EP? Q1 minus Q for this charge on upper plate, upper surface. For this, there will be, for this Q1 minus Q2, for this Q1 minus Q2, Q1 minus Q, there will be charge here. This P charge on the lower side, and there will be charge on field. There will be field on the upper side. There will be field in the lower side. But this upper side is not in my business. I shall take only lower side. That means, what is the surface density of the charge? Q1 minus Q divided by, let A समान surface area of each face. Surface area of each face. Then it has two faces. There is surface density sigma Q1 minus Q divided by 2A, total charge by total area, that will give me sigma by 2 epsilon. Q1 minus Q is only on the upper surface. That means it will be Q1 minus Q by A. What is my field? Sigma by 2 epsilon. This is on due to this field is due to Q1 minus Q. On which side? This lower. Okay, this is on lower side. Due to this charge, what will be the field at P? Q by twice epsilon 0, but this will be on upward, so minus will be there. I have taken lower side positive. For this minus Q, what will be the lines of force? In this direction. Due to minus Q, lines of force, field will be in this direction, lower side. Minus Q will be in this direction. Okay, so this will be positive. Q by twice epsilon 0. And for this Q2 plus Q, what will be the field at point P? on the upper side. That means minus Q2 plus Q divided by twice epsilon 0. Total summation, this is on lower, this is lower, this is upper. That's why negative. Okay. Now let us see what comes out. 2 epsilon 0, 2 epsilon 0, 2 epsilon 0, all cancel out. Q1 minus Q minus Q plus Q minus Q2 plus Q, that means minus Q2 minus Q, this is equal to 0. And what ultimately comes out? Q1 minus, this is Q. So twice Q equal to Q1 minus Q2. Okay? So Q equal to Q1 minus Q2 by 2. Problem solved. So what will be the charge on the upper face? Upper face of the upper plate. What will be the charge on the upper face of the upper plate? Q1 minus Q. That means Q1 minus Q2 divided by 2. What ultimately comes out? 2Q1 minus Q1 plus Q2. That means this will ultimately comes out to be Q1 plus Q2 divided by 2. Right? Q. This is Q1 minus Q2 divided by 2. This is upper A. And what will be the charge on B plate upper face? B plate upper face. This is B plate upper face. This is Q1 minus Q2. Opposite. That is minus Q1 minus Q2 divided by 2. And what will be lower face? Q2 plus Q. Q2 plus Q. What is the Q? Q1 minus Q2 divided by 2. What you get? That Q2 plus twice Q2 minus Q2. This is Q2 and again Q1. So Q1 plus Q2 divided by 2. Q1 plus Q2 divided by 2. That is the distribution of charge. And curious, interestingly, you see that on upper plate, upper face and upper face of the plate A is equal to charge on the lower face of the plate B. Extreme faces, extreme surfaces will always have equal charges. That tricks you have to remember, and you will solve easily this problem. I will not go into this elaboration. It is just for explaining the problem. Let us see. I shall apply the trick. How you will solve this problem? 3 basic principles you have to remember, keep in mind. You have to memorize. Number 1, charge on outermost faces of the combination. Outermost faces will be equal. Okay, this principle you will apply. Isolated system has I don't want to refer to it because it is an established fact that from conservation of charge we know that any isolated system has its charge conserved. I will not write it. But next, surfaces facing each other, facing each other, will have equal and opposite charge. Equal and opposite charge. Okay, this is right. Now you try to solve it on this principle. You see how much time you need. I am solving it from this principle. Do it fresh. This is upper plate, this has charge Q1, this is lower plate, this has charge Q2. Let us consider this surface will have charge Q. Then from conservation of energy, this surface will be Q1 minus Q. These two faces opposite, minus Q. And this is the outermost surface. This is the outermost, two outermost surface will have equal charge. Problem solved. Q1 minus Q plus Q equal to Q1. Okay. Total system has charge conjugate. That means Q1 minus Q plus Q minus Q plus Q1 minus Q. This will be equal to this. This will be Q2 minus Q. This will be Q2 minus Q1 minus Q. Oh, this will also from the principle. If it has Q1 minus Q, this will also. Okay. You don't. This total charge of the B plate will remain constant. What is the total charge? Q1 minus Q minus Q. This is equal to, before induction, what was the charge? Q. So, Q equal to Q1 minus Q2 divided by 2. Okay. What will be the charge on the outer surface? Problem solved. Then what is the charge in this plate? Minus Q1 minus Q2 divided by 2. What is the charge? Plus Q1 minus Q2 divided by 2. Okay. What is the charge? Q1 minus Q. That means Q1 minus, what is the value of Q? Divided by 2. This will come out to be Q1 plus Q2 by 2. If this is Q1 plus Q2 by, this will also be Q1 plus Q2 by 2. Q1 plus Q2 by 2. In very quick time, I got the answer. Okay. This has plate Q1 plus Q2 by 2. This plate has Q1 plus Q2 by 2. This plate has Q1 minus Q2 by 2. This plate has Q1 minus Q2 by 2. I am giving you another same kind of problem for you to solve it. For you to try. Let us go to the next problem. This problem is taken from AC Verma. I hope that each of you has AC Verma at your disposition, because for JEE or NEET, AC Verma is essential. Okay. 3 plate. Find the charges on outer surface of the rightmost. Suppose this is A, B, C. This is rightmost. A is given Q charge, B, C is given -2. This is neutral. Okay? That is the problem. Now you have to find, you can find distribution of charges, but you have been asked to find only outermost surface, this surface of the outer surface of the rightmost. You pause it and apply the principle I have told you, that outer surfaces will have equal charge, surfaces facing opposite will have equal and opposite charge. Beyond these two principles, you will easily solve the problem. Suppose this has Q charge on the inner side surface. Then what will be the charge on B? This surface minus Q and this surface plus Q. Why plus Q? Total charge of this plate, B plate is 0. So if it is minus Q here, then obviously it will be plus Q on the other surface. Again apply the principle. Here it will be minus Q and total charge is concharged, then it will be minus 2Q plus Q. This is the charge on the outer surface of the rightmost plate. Then left surface of this plate, what will, these are outermost surface, these are outermost surface, then what will be the charge? Minus 2Q plus Q. It will be equal by principle. What principle is given? Thumb rule, by thumb rule. Okay, minus 2Q plus Q. Now apply this principle. This system, charge of this system is will be conserved. What is the charge of the system? Minus 2Q plus Q on the left face, on the right face. And total charge was previously was Q. So what will be the charge? Q equal to 3Q by 2. This will be the charge. We have got value of Q. Now you find outermost surface. Suppose this is Q dash, then what will be value of the Q dash? Minus 2Q plus value of Q 3Q by 2. 3Q by 2. What will ultimately come out? Minus 4Q plus 3Q. Minus. That is my answer. Okay. You can easily reach the answer by applying this principle. Let us go to the next problem. This has also been taken from H.C. Verma, problem number 23, chapter 30, that is Gauss's law. You are given two plates. It will be mentioned that surface area will be very large, otherwise field will not be uniform. Okay. This is X plate, this is Y plate. X plate is charged, Y plate is neutral. Okay. Find surface density at inner surface of the plate. A surface density we have to find out. Electric field intensity at a point to the right of place. At any point to the right of the place. And midway. Number 3. So apply the principle. Suppose this surface has Q charge. Then this will have minus Q charge. Total charge is 0. Then this will also have Q charge. Okay. What will be the charge here? This will also have Q charge. If I take, it will, no. It will, how I can total charge is 0. Total charge is 0. This will also be Q. This will, if this is Q, this will also be Q. Okay. In this way you can proceed. Q, I have taken it Q. Face opposite. This will be minus Q. Total charge 0. This will be plus Q. And if this is plus Q, this will also be plus Q, because these are two outer surfaces of the combination. Problem solved. What will 2Q? This is isolated system. Then total charge will be equal to Q. you have found the value of q by 2. This is the, now you find, okay, you have to find the surface density of charge. What will be the surface density? Each surface has area A, then q by 2a surface density. This is my answer, number 1. Now you find the problem, find the electric field intensity at right side of the combination, at any point on the right side of the combination. What will be the electric field intensity? Suppose in this direction, I don't know in which direction will be the electric field intensity. I have taken in this direction. Then due to this, what will be the electric field intensity? Due to this, q by, this is q, this is q, this is minus q. For this, surface density of charge will be also q by 2a. For this, surface density of charge will be minus q by 2a. And for this will be again q by 2a. Okay. For this sigma, what will be the direction of the electric field? In this direction. Suppose this direction is taken positive, so then q by 2a, that is my sigma. Sigma by 2 epsilon, this is a charge sheet. Sigma by 2 epsilon 0. So sigma is q by 2a and 2 epsilon 0, that is sigma by 4 epsilon 0. Due to this, what will be the field in this direction? Then it will be minus q by 4 epsilon 0. Due to this, field will be in this direction, plus q by 4a epsilon 0. Due to this, also in this direction, q by 4a epsilon 0. This is my total field on the right side. Okay, q by 4 epsilon 0, q by 4 epsilon 0 cancel out. What is the answer? Q by twice a epsilon 0. This is my answer. In this way, you find the field at the midway. This will also come out to be q by 2 epsilon. Just in this way. Okay, in this method you will approach, and here it will also, the electric field will be in midway q by twice a epsilon 0. My video I shall finish here. In next video, in very quick time, I shall give another concept, another 2 or 3 conceptual problems that will help to boost up your concept and confidence. Okay, that topic I will later decide. Thank you very much. If you like my class, you will not forget to give like and subscribe my channel. My channel is CHR Physics. I shall give the link in description box. I hope you will appreciate the class, and I will take these short classes and many short classes on the subject of electrics. Then I will switch over to another topics. Okay, thank you very much.